Hello everyone, this is Bradley. So earlier I've made a folding fan or hand fan or whatever you call using animation nodes. It's completely procedural because I need to animate the opening of this kind of fan within 3D software. I later also proposed the idea and made a tutorial talking about how geometry nodes will approach that kind of cloth part of the entire thing. But obviously it's just making a cloth part. It's not really finishing anything. And then we do have some issues about UV and many other stuff that you need to worry about. In this particular case, I think it's kind of very worth to talk about how animation nodes can actually approach this problem to make a real fan completely finish the entire whole thing procedurally. And also to know that there is a Discord server made to discuss animation nodes. If you're interested in, the link are all provided in the description and so on and so forth. So let's just start. So within animation nodes, I'm going to hit Ctrl A and search for circle mesh. This is one of very few nodes that animation nodes provides natively, talking about this different mesh generation. Other nodes like grid mesh or cylinder mesh, but animation node, since it's not really designed for mesh modeling as Procedural, it only provides this many nodes. This node, however, is very powerful. If you go hit U and it goes to the socket settings, there are many hidden socket sections. So let's take a view. So let's mesh object output so that we can see the object that we're creating. So this is just a normal circle. There's nothing really special. But if you disable this merge from starting from end, then you can actually control the angle about how much this fan actually goes. This also means if you take that to pi, and you can control this start angle to define how much this fan is opened. Okay. Another thing is if you disable this merge from centers, then you start to have a inner and outer radius control. So you can have easy control about how this fan has been manipulated. So let's go to wireframe mode so we can actually see how the wireframe has been distributed. So the loop part is completely procedural. In this particular case, I think I'm going to take a float mass and times that to 2 because we need to take an integer input. Because it will be better if our radial loops is defined every second. So it should be an even number. It will be better for later manipulation. The inner loop is basically subdivision, but for actual fan, I don't think it is meaningful anyway. So I'll just keep that as 0. Next thing that we're going to do is to basically elevate every second row. So in previous geometry nodes tutorial, if you have watched, so basically we use math functions to make a modulo. Here we are going to use another function which is called ID. So we're going to use the set offset vertices. And everything has been lifted up because the fourth is 1. So we're going to make the fourth basically masking out every second. So we're going to use a index mask fourth. And basically once you apply that, immediately you get the results. And this is our fan, and this index, because the index does not change, the second is always the second. So we do not need to worry anything. You just make it open and close. If you do not worry about the length change, because in real life, when this folds, then it does not go on the same plane. So let's go to the X. So while we are actually closing these entire fans, you can see it's always on the same height. But in reality, if you think about this, it should not go on the same height. But definitely you can manipulate this, like use a float inputs and take a map range to manipulate the height change, so that to make it a little bit more realistic. But in this case, I think I'm not going to do that, just to simplify the workflow. Just getting an idea, you can do this by yourself, okay? Next step that I'm going to do is to make kind of a stick. So I'm going to model a stick because I think it's kind of more easy to control. and I'm going to make the stick origin on one end. And you can take the solidify modifier, take a solidify modifier. Actually, probably we do not need a solidify modifier at this stage. So let's instance our stick to our fan. Basically, I'm going to use a node which is called the transform mesh. This transform mesh node, I've explained in many different cases that it can also use for instancing. And to load our stick, we need objects mesh data nodes, and select our cubes, a plane, and then we need the transformation. The transformation must come from the mesh. Basically, we want to instance on the center of each polygon. In this case, which we can directly use distribute mesh nodes and set the type into polygons, set the type into matrices. So we need to finally again output our mesh back and add another target. So at this stage, I think we can properly name the cloth part and stick, and we can also take a stick unit. I forgot to mention, however, is because we are working with a plane, so we can definitely use the grid mesh node. You just need to make sure you're offsetting the length or width, or this. You can use the step which is better or easy to calculate. Basically, you can replace so that you are not going to use the plane kind of stuff. But I think being able to manipulating with the within the viewport is kind of nice. So once we have all this kind of stick, you can see the pattern. What it shows is that there's one goes that, the other goes out, the one goes in, the other goes out. I think this is fine because we are going to mask half of side anyway. So here what we're going to do is we are going to use a mask list. However, I do have a preset which is called a mask matrices. Basically, this node with is inside, and it attached to the for to define the selection. The for is basically a mask, as you can see. In this case, since we're going to mask every second row, then we definitely use the index for again. So you can actually use the same for, it does not really change anything. Just to make node tree better, I choose to use another index for, but technically speaking, they're doing the same. I need this every first actually, so I need the offset to get to 1. So now we have everything works. It's just it has a little bit wrong, but if you look offsetly, probably right. So the orientation is not something that I would like to fix in really. If you would like to hide that this to back, what you can do, I'm going to take the offset matrices. It does not really matter this offset matrices is before or after the masking. I think it does not really change anything in my opinion, because it does not really matter. So anyway, so first thing, I would like to scale this down. There are two methods to scale this down. One method is you can manipulate the mesh directly. Just to know that if you manipulate the mesh using this object mesh data, you always need to reclick so that update the information. Okay. Another method is definitely control your node tree so that you move everything up and down, whatever. Another thing is if you try to rotate this stuff, because we will encounter this kind of problem. So now it does not look any kind of problem, but if we try to change these angles, you can see there's some issues with the fan. Maybe it looks normal, but I don't think this is normally what happens. So it should look more kind of like this. So you do have, we're not going to use the wood space, but you need to kind of more set into middle. So fan should really go like kind of circle, so that the origin must located at the origin. Okay, so you need to be able to rotate this stuff, make a little bit of correction when this thing does not go right. In this case, another thing, if you would like to hide that in the background, I think you can do a lot of things, but I think the easiest way that I would do is wait. So I'm going to hit use, rotation to local axis, translation to local axis. So that's manipulated, yeah. You can manipulate to -z so that it goes to against the normal. So hide a little bit better. You can also change Y so that it depends on how it cross. There's also other values that you can potentially play around, but I think this is it. And again, deal with the rotation by itself. Finally, to open up everything, just to change the start angle. If you need a kind of small tweaking because there's definitely some bugs that occurs, you again use floater input and map range to deal with all this kind of opening up and the values, to kind of small tweaking to make it look more realistic and better. One thing that we do not have thickness within this fan. So here what we do is we basically take a solidify modifier and I'm going to take a bevel modifier to kind of make it look nicer. One more thing is that if we were trying to create a mesh within animation nodes, you always need to shade smooth manually with the nodes. Actually, not manually, but you need to do that with nodes, otherwise it will not work. But one thing that's working, however, is the auto smooth. Just to know that auto smooth does not mean it will automatically shade smooth your object. It only means there is a limitation of the shade smooth so that it can reduce the artifacts in some point. It's just like if you have a cylinder, and if you try to shade smooth, you will have this kind of dark edge, which is kind of very ugly unless you turn on this auto smooth. So it smooths out, but it does not have that artifact. Kind of just basic knowledge of Blender usage. Next thing I would like to discuss is the UV. So now if we go to shader and select our fan objects, and I do realize here I do not know why I actually named that wrong. I should name that as a fan and the plane as a stick unit. Okay, so within our fan, let's add a materials. Control T, add image textures, and select our image textures. And then let's go to nodings. Go to our material preview node. You can see actually nothing works very well. The reason is that if I go to the UV editors and select the node, it does not really show anything. And then if we hit the tabs, goes to the edit mode, you can see there's no UV. If you do not have UV, how can you actually put the image texture on the top of UV? So, and you can, it's not recommended to use other mode because once you are folding these fans, generated will also change, the object will also change. So nothing is better than UV in this particular case, but you do not have a UV. So to get a UV, there's multiple methods. So one method is I'm going to duplicate these fan objects into another place, and then I'm unwrapping this object instead. So I'm rotating this UV map and probably scale it up. So manipulate it as you wish. So now we have these mountains. Once we have these duplicated objects, we are going to import this UV map to our target mesh. So what we do is first we take an object mesh data. So I'm going to select our duplicated mesh, get UV map, and insert UV map. Place that before the creation of our fan. So if I link that mesh to mesh, we need to type the name of our UV map. By default, the UV map is always created as the capital UVM and letter case, smaller case, the AP. But it says the mesh does not have a UV map with the name UV map. The reason is that you need to go to the object mesh data, hit use, go to socket setting. There's hidden setting as the load UV. So you just enable that you load UV, you immediately get the results, and then you import that. So this is one way to do that. A very good part is that if you try to fold this fan, it'll go with that, and this is why we need UV. Another thing is that even if you increase the count input, it will give kind of weird result, but it's not really destructive. It's just looping the UV over again. So you can repeat the same process. I don't think it's kind of too bad. It's still a very nice workaround that you can tolerate. So plan ahead before you actually work. So this is just one method. There's, however, another method which we are not going to use. The other objects method. It's kind of more procedural methods, if I were to say. So here we still need the insert UV map, but we are going to procedurally generate a UV map for our object. So here, instead of a curved mesh that we generated, curved UV map that we generated earlier, I'm going to use a grid mesh because animationals provide this kind of grid mesh for you. And instead of, I think I'm just firstly get everything into 2, 2 because it's just 1, 2. So in whichever axis it should be 1, 2. But then we can plug these numbers into x-axis. I don't think this is the right, but we will see this later. So once we have all these kind of things, another thing is we need to know a little bit common knowledge about shaders. Basically, shader UV map is always range from 1, 1. By default. So it does not really matter which size, which dimension, which the ratio of length over width of your image texture and so on and so forth. The UV map always range from 1 to 1. Okay. So at least set that to 1 to 1 and we will see the effects very soon. So once we get the mesh, another thing is before we plug that into position is we need to have a mesh info. And we can plug the vertex locations, but what it happens is, you can see this is what happens. The reason is that the UV map actually calculates each face independently to each other. So the vertices amount should be duplicated. You may not actually really understand what's actually happening here, but I'm just going to separate the polygons and put the polygon indices to place, and immediately you can see we have a nice grid. But for some reason, it just does not look right. So we can rotate this until we found a kind of solution that we are happy with. We know how this model really looks like. In this case, we still really looks like nothing's right. The reason I think is that for some reason you just have to flip that until it looks right. So another issue that you realize at this moment is this grid, or the grid mesh, is always produced at the central origin. So we have to do a little bit of manual labor to offset things a little bit. So to make our life a little bit easier, I think I'm just going to use a viewer to see about what actually we produced, because we cannot read everything in UV correctly. So I'm going to take the transform, and we can take a translation matrix to move that to maybe 0.5, 0.5, and 0.5. So now we just make everything like 1, 1. So it fits all the UV map, but it does not really look like something we want. So I'm going to rotate this 90 degrees. So now everything looks right. You just have to deal with something about scales, so this UV map looks kind of better. So now I think this is the correct way that how it looks. Okay, and it's kind of procedural that you can start with your angles, other things. More importantly, if you increase the count, previously we just have the loop of the UV map because it's copied from other objects, but in this case, because everything is being procedurally produced, you do not need to worry about that. You just increase the count, it will just stays there. So this is it. Another thing is for our sticks, the same problem will occur because, but however, we're using the object from the stick. So you put the material for the stick. Take the stick, but you can load the UV for sticks and then do whatever manipulation. Or if you want a different stick to have a different coordinates, because otherwise they will look the same, which they have the same UV and so on and so forth. You can also use the object instancer method to instance the object so that each object are independent to each other. Or in the worst case, you can use geometry nodes. Maybe you can import this information to the geometry nodes, and then geometry nodes will load all this kind of information and instancing these things for you while keep every object independent to each other. So these are just the kind of concepts. And you only take these nodes, and I think it's kind of important, despite the eevee part is a little bit long, but the rest part is just these minimal nodes. Kind of nice and easy compared to geometry nodes, in my opinion. There is one last thing I forgot to add, however, is that in real life, if you're looking at the fans, these fans, the last one should actually goes up to cover the fan, not down. Not everything is down or going back. So in this case, there's actually billions of ways. Just to make everything a little bit convenient, I'm just use a new offset matrices. I'm only going to affect the last one. So firstly, I need to define what kind of conditions that it will actually help to move this entire thing upwards. So actually, that's not really work. So I'm going to take that into global axis, and then try to move that on the axis. But I want to have this effect to work on only the last one. Okay. So the way to do that is that I'm going to use basically how should I say? There's really many different methods, but I just try to use the fade evolve. This is not necessarily the best method, but this is most convenient method in my opinion. And I need amount. I can get amount from anywhere, matrices, vectors, whatever place. As long as the amount matches, it does not really matter where do I get this amount from. So once I have this fade evolve, you can see there's a gradation from this to that object. We're going to make the gradation very sharp. So construct interpolation and take the exponentials. So it affects the last one. The exponential, if you would like to take a view, you can see how this looks. So this is a kind of very sharp angle. Okay. So then you deal with these kind of values to kind of mimic the effect. And you can deal with the rotation to make it kind of looks better. But this is kind of concept about how you do this. And definitely you need to deal with a kind of flaws. And another thing is, once you produce all these kind of objects, what I will recommend you is I'm going to hide this stick unit. I actually instance to scene and rotate this as an individual object and animate that independently, so that it makes things a little bit easier. Just take this duplicated fan. Since we're not going to use this, we can delete this. So now we have a fan. Okay, it works pretty nicely. Maybe you would like to offset, but generally I would say this is fine. So I think this is generally quite easy things, especially you only have these knowledge trees to do this kind of simple work. So I hope you enjoyed this tutorial. I'll probably see you next time. Bye bye.